Okay, hello all you crazy people out there. My name is Michael, I like wizards and dragons and making games, and let's talk about 3D games in GameMaker. This one's been a long time coming. Welcome to the beginning of my series on 3D collisions in GameMaker Studio 2. I've made a few videos on 3D collisions in GameMaker in the past, but those were DLL-based solutions, which, to make a long story short, they work on Windows only and they're not great for portability. And by far one of the most common tutorial video topics that I get is 3D collisions in native GML. So that's just regular GameMaker and it doesn't require any external tools to work. And you can just use the code for regular GameMaker, whether you're making a game for Windows or for Mac or for Linux or a cell phone or HTML5 or the Nintendo PlayStation or whatever. Now, how I am going to go about handling 3D collision is that if anyone was hoping for just a simple video, maybe 2 videos on making 3D collisions work in GameMaker, then I am really sorry, because that is not how this is going to happen. So, there's a lot to 3D collisions, and if I were to bring up my good old, to-do list here, there is a lot of ground to cover, and I'm going to be making this a regular series on my channel for some time. There's going to be different aspects to 3D collisions. There's going to be basic shapes, having basic shapes collide against each other. There is going to be having triangles collide against each other, because that is an entirely different story than just checking to see if 2 spheres overlap. We are going to be talking about raycasts, which is for checking to see if a line intersects an object, which can be very good for things like bullet collisions if you're making a first-person shooter. As well as just, and I guess I can scroll down this list a little so that you can see what's coming up, as well as just some other general ways of organizing this. And you can see the dates on each of these little cards is when I'm hoping to have these videos done, although the dates aren't set in stone. There are also a couple of collision shapes which I want to cover in this series, such as capsules, which are like long spheres, and oblique bounding boxes, which are just basically rotated rectangles. But I have not completely decided when that's going to happen yet. Those may fall somewhere in the middle, they may fall towards the end, we'll see. So if we go back up to the top of this list here, this is going to be episode 0, this is going to be a bunch of project setup. Let me jump into the project that I'm going to be working out of in this series for the next dozen or so videos. So what you see on the screen right now is basically all there is. There is just a grid on the ground, as well as some red, green, blue, X, Y, and Z axes. And this is all just here. The world is basically a blank stage. This is all just here so that we can orient ourselves and have a better sense of where things are when we're looking at stuff in the world as we're working on things and testing collisions. Later on in the series, I'll probably actually put this in an actual game, and we can do some experiments with gameplay, but for now, the world is just an empty stage, and we're just going to be doing some experiments on here. I do have, as well as the actual grid itself, I do have a bunch of different basic shapes. These are going to be the basic shapes that we're going to be working with right now. Those are going to be the cube, also known as an axis-aligned bounding box, a plane, which is just a 2-dimensional sheet, which, for all intents and purposes, extends off into infinity. There's going to be a single point, which is supposed to represent a point in space, although since I can't really do that visually very well, it's actually just going to be a tiny sphere. And then there's going to be an actual sphere. So if, for example, we wanted to draw one of these, we could vertex submit sphere, not a triangle list, not a triangle fan, a triangle list, and no texture. And this is just going to draw the sphere at the world origin. We can zoom in and see it better. And we can also see that there is just a directional light on it. And it's not fancy, it's just a simple directional light. And this is just so that we have a sense of depth to the world, so that it doesn't look as flat and that it's a little bit easier to see what's going on, for example. So that's that. The shader is very simple. It's just a directional light which is running in the fragment shader. Okay, this is going to be in a GitHub repository in the video description, as usual. I'm probably going to be doing something like I do with my Tower Defense series and marking a release each week, so that you can view the state of the 3D collision project each week. So again, what we're going to be doing at the beginning is we are going to be working with these basic shapes and having them detect collisions with each other, as well as raycasts and line casts against them. And later on, we'll be getting to more complicated things, such as 3D objects. So there is a little bit of knowledge that I'm going to assume that everybody has before we go into this. If you're not familiar with all of these things, it's not the end of the world, but it really would help if you were familiar with these things. One is going to be basic 3D rendering. I'm not doing anything complicated here. I'm not doing anything insane with shaders or anything like that. But I am going to be just plopping in 3D objects into the world. with some matrix transforms as necessary, and just assuming that vertex submit on a vertex buffer isn't going to be that bad. If you are not familiar with these things, I have good news, and that is that I spent most of the entire last year and change making videos on these subjects. I'm not going to say that 3D collision code is easier or harder than 3D rendering code, but I will say that it is sort of a different sort of programming tasks that you'll be seeing. 3D collisions is a lot of geometry and analytic geometry and that sort of thing, whereas drawing stuff in 3D is a lot more, dare I say, visual? Writing shader code tends to look a lot different than writing 3D collision code at any rate. You are, however, going to want to know a thing or two about vectors. Vectors are going to be coming up a lot. Vectors are something else that I've made a video on in the past. I'm tempted to say that we're going to be seeing a lot of data structures in this video, but it's probably going to mostly be arrays, as well as structs. In addition to just vectors, matrices will be coming up eventually, and we are going to be using them in a more in-depth way than you would if you were just writing shader code. Although that's something that I'll be dedicating time to explaining more thoroughly when we need to. Matrices are kind of one of the reasons why I'm putting off rotated blocks, oblique bounding boxes until later in the series. Recursion is going to come up later in the series when we get to organizing a 3D world into a hierarchy to speed up collision checks a little bit. There's a part of me that wants to say recursion isn't too scary, but I know that some people like recursion and dealing with recursion a lot more than other people. And some things that would be helpful to know about, but aren't really required, are bitwise math. You can use a little bit of bitwise math to filter collisions and only detect collisions with certain objects fairly easily, but it's by no means necessary for the main part of what we're doing. And runtime analysis. Runtime analysis is the scary sounding word for figuring out which part of your code is running the slowest, and which kinds of code would be faster if you have large numbers of 3D objects that you're working with, but it's by no means necessary for the basic principles of collision checking that we're going to be dealing with. On that note, I will not be writing perfect 100% optimized code here, and that's going to be by design. I want this code to be easy to read over everything else, and once the code is working, if you're a GameMaker power user and you like to optimize things, that is the point where you may want to look at the code that you've already written and start to think about how you can shave off a little bit of extra performance here and there. Perhaps using an array instead of a struct for something, or using a macro function instead of a regular function for something. But do be warned that GML is a relatively slow language, and I will be putting readability over performance in a lot of cases. Although, if you are curious, this is definitely the sort of code which using the Yo-Yo compiler can dramatically help to improve performance. Okay. What else is here in these notes that I wanted to say? Okay, this series is going to be pretty closely, at least at the beginning, based on Gabor Sauer's excellent game physics cookbook. That is a physical book that you can buy. I believe there's also a digital version if you prefer to have an ebook. But that is going to be where I learned a lot of the math that I'm going to be showing in this video. If you are someone who does prefer to learn out of a book rather than a YouTube video, you may prefer to just use that instead of the series. It does focus on writing code in C++ and straight C++ rather than in GML. So you will have to do a little bit of work converting from C++ to something that looks more like GML. But I found that the book is pretty helpful overall. Do be warned that there are a lot of typographical errors. Not so much in the code itself, but there are quite a few typographical errors in the explanations of the code. Let's just say that the book is good, but it does make me ask some question about what the publisher and the copy editor were doing before they sent it to the printers. Anyway, I swear to God, Gabor Sauer is not sponsoring this video, but if he wanted to for some reason, I would probably not say no. I will also say that if you are not someone who's interested in implementing 3D collision math, all this 3D collision math from scratch yourself, there are a couple other solutions. You can use the built-in 2D collision system for use in 3D in GameMaker. That's a valid strategy, a lot of people do that, and it works fine as long as that fits within your constraints. Like I mentioned earlier, there are DLL-based solutions that you can use, which are quite rigorous and quite good. There was also more recently, the Heavy Metal Viking Dentist, one of the legends of GameMaker. I think you can find him on like the second floor of Cerulean Cave if you have all 8 gym badges and you've entered the Hall of Fame and that sort of thing. He himself has made a fairly robust 3D collision system which you can use, and it works in native GML. It works as a GameMaker extension. And if you just want to use a 3D collision system in your game that you know already works so that you can get on with making the rest of your game, I will have a link to where you can find it in the video description. I have not made any videos about how to use it or anything, but I want to eventually, and I think there's enough documentation out there on it that getting it up and running shouldn't be too bad. Alright, the next video is going to be setting up a lot of basic shapes, and we're going to be setting up a little vector math library that we can use for the rest of the series. I know this is getting off to a slow start, and I know a lot of people probably just want to get into the action, but this can be a rather big subject, and I don't want to make it feel like we're just jumping in the middle without any explanation. Anyway, I hope you're all excited to see more of this. The next episode should be up next week, and after that, once things get settled in place, this might end up being an every other week series. Although if I have time to make them more often than that, I will. Subscribe if you want to see more of that. Otherwise, I do try to post about 2 game dev videos a week, one of these and one Let's Make a Tower Defense game, as well as a whole bunch of Let's Plays. I have a Patreon, so if you want to contribute towards these videos being made, there will be links to that in all the usual places. If you want the code, if you want the project that we're going to be working out of, look for the GitHub repository in the video description. Again, look for the I guess this would be like 0.0 release, which is going to be the base project. Otherwise, I hope you all are as excited about this as I am, and I will see you all later. Special thanks to Kiara Elizabeth, Connor, David Key, Edward Holt, Emily Koyo, Gregory, Posho, Tusk, and Zenith for supporting these videos. If you want to see your name in the credits or to hear yourself shouted out at the end here, head on over to the Patreon page in the video description to join the fun.